Chapter 10 starts off with section 1, and we're doing square roots of perfect numbers. Or as they call it, square roots of perfect squares. And so this part of it, this is where you're going to be doing just your basic numbers. That if you're doing square root of 64, well, that's just 8. They're going to do square root of 25, which is 5. Square root of 36, 6. Square root of 49. So they're going to go through those whole list of numbers where you're just going to do one number times itself. So basically, you're almost where you can kind of go back and just make a list of numbers. That if you've got 1 times 1, that would be 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Then they somewhere, if you have the textbook, they give you a list of those. You can just go back through and just write down all the numbers where you're doing one number times itself. That if you do the square root of this, and this is what they would call the perfect square numbers. And you can keep on stretching that list out, but these are your perfect square numbers. That if you take the square root of this number, you're going to get whatever number was you multiply by itself back when you go through those. So that's really the kind of the big thing they're looking at in chapter 10, is having you start off with just realizing that, okay, we've got these perfect square root numbers, or these perfect square numbers, that if you take the square root of them, you're going to get just a nice, perfect answer back from it. Okay, in the first few questions, they're going to give you those basic numbers, like 64, 25, 36, 49, just all those kind of numbers, and have you just go back and just take the square root of it. And most of those numbers you're going to be able to just look at it and recognize it. And then what they're going to do is, once they've gotten you used to just doing a few of these numbers where you're taking perfect square roots, they have you working with Pythagorean theorem. Now, the one thing with this one is, and they don't quite get to it yet, but I'm going to go ahead and tell it to you. If you do the square root of a negative number, that's a no solution. That when you do square roots, it always has to be a positive number. So if they do happen to give you square root of any number, doesn't matter what the number is, if it's anything negative, it's always going to be no solution. Now, again, they'll kind of come back to this a little bit later and have us do some more with some of the perfect square roots and the different things with it. But before we do that, we're going to go ahead and do some with Pythagorean theorem on these. And basically is this. What Pythagorean theorem is, it's just you're still going to do square roots of numbers, but it's just a setup to kind of get you there. And basically, here's what the Pythagorean theorem is that if you have a right triangle, and how you know what the right triangle is they always give you a little corner right here, and they'll put a little notch in this corner to let you know that that's a right angle. Is that if you take the three sides you have, then the two sides connected by this right angle, by this little box in the corner, those are what they call the legs. That if you do a squared plus b squared, that's going to equal c squared. And what they're going to do is they're going to give you numbers that basically you're still going to square root the numbers at the end. You just got to do a little bit of work to get to the point where you can square root some numbers off of this thing. All right, so let's give you one where we've actually got some numbers here. Okay, and C is always the longest side. And that one's called the hypotenuse. A and B, those are your shorter two sides. Those are always called legs. Okay, and again, the main thing on that one to know is that when you talk about the A and the B and the C, the main thing is what C is. A and B are kind of interchangeable. It doesn't matter which one's which. But C is always the longest side, and it's always the side that's not going to touch this little notch in the corner. So A and B will always be connected by that little right angle in the corner. C will always be the side that's over here by itself. Okay, so if that's the first triangle that they give to you, and there's really only one of two triangles they can do for you here, is in this case, you've got A and B connected, so if you plug these numbers in, we've got 21 squared plus 20 squared, and that's going to equal x squared. Okay, and most of these problems, it's really calculator practice. You're going to do 21 times 21, which would be 441. You're going to do 20 times 20, which would be 400. And then you're going to add these two numbers together. Okay, and once you've got these two numbers together, add them together to get to this point, this is basically a problem basically like this, that now that you've got this answer, they're going to ask you to go back and take the square root of it. So now you go back to this thing to get it by itself, is that you're going to take the square root of both sides. Okay, when you take the square root of x squared, that's going to give you just x. And when you take the square root of 841, that's where you just use your calculator, because nobody really knows that right off the top of your head. Use your calculator, do the square root of 841, and that one you get 29 for that. Okay. Now, if you've got your calculator out or not, if you get one of these, everybody's calculator works a little bit different. If you get 841 and you don't know where your square root button is for some reason, just let me know. I can show you what that one would be, where to find it. Okay, so there's one problem. And again, there really are only two problems you could possibly get. Okay, this time still going to be the same thing. They're going to tell you to use Pythagorean theorem to find the missing value. And for this one, here's your right angle, here's your notch in the corner, so this means your A and your B. So if you have A squared plus B squared equals C squared, X and 9 are your A and your B. And again, the order doesn't really matter which one you put there. The one thing that's important, though, is that your C value is 12. C is always the longest side. You know, if you want to, on the inside, you could go back and say that's A and B because they're right beside the right angles, which means that would have to be C over here. Okay, now for this one, where they give you the C value, the difference is after you square the numbers, x squared is over here with 81. You have to subtract the 81 first. Subtract that. This one you wind up with 63. Now, if you 64 would be a perfect square root number. This one's a little bit less. So this one, they tell you when you get finished with this one, you're going to have to round the answer off because when you square root both sides, well, it's not going to be a perfect square root number. It's going to be just a little bit off there. So that should be 7 point. Let's see what that's going to be. I said round it to 2 places, so 7.94. Okay, and once they've gone through and kind of gone through Pythagorean theorem, still doing square roots, they're going to change gears just a small little bit. And it's a small change in the wording, so this is where you have to kind of notice what they do here. It says find all square roots of a number. And that one little thing, square roots with the S on the end of it. Because on the first problem, it just said find the square root. So you're looking for one answer. This time you're looking for 2 answers. So they're going to tell you it's 121. Okay, now you still take the square root of 121. Would equal 11. Now, if they say find all square roots, they're kind of throwing a little curve at you, because on this one, it's almost like in reverse. Because if you do 11 times 11, that would be 121, right? Okay. What if you do negative 11 times negative 11? Isn't that also 121? So they're saying, all right, now if it says find all square roots, it could be positive or it could be negative. So now you're looking at 2 answers. It's all in the wording. On the very first problem, it's going to just say find the square root of this. So the very first problem just said find the square root, where you're just getting one answer. When you get to the 4th or 5th example, whichever one you're going to, it says find all square roots with an S on it. That means it could be positive or it could be negative when you're going through that one. So that's one of those where you just have to kind of pay attention to how they word those. Okay. They go from whole numbers. That's example 1. Example 2, they give you a fraction. So you've got square root of 45 over 80. Now, you can do this one a couple different ways. But for these fractions that you have, for just a moment, just forget that you've got a square root there at all. If you have 45 over 80, could you simplify that fraction? Both ends in zeros and 5, right? So you know for sure you can divide out of 5. So go ahead and divide them both by 5 and see what you get. 45 divided by 5 would be 9. 80 divided by 5 would be 16. Okay. And then realize that you did have a square root there. Once you got down to 9 over 16, you can break it into 2 parts. Because what's the square root of 9? It's 3. The square root of 16 is 4. There you go. So simplify the number down as much as you can. And once you've got the number simplified down as much as you can, then you should be able to break it up and do the square root of the top and then do the square root of the bottom to get the answer you're looking for. Okay, so with the negative on the outside, we're doing square roots with signs where we've got the negative. If the negative is on the outside, it doesn't impact it at all. You just do square root of 25, which is 5, and the negative's in front. No big deal. But if the negative is on the inside, that's where you can just go ahead and say that's no solution. So a negative on the outside is just a marker. It's just there, but a negative on the inside messes the thing. And that's one of those, if you do it on your calculator, it's probably going to, it's going to give you an error message to let you know you can't do that. Okay, so then we're doing square roots of integers raised to even exponents. Anytime the number on the inside is negative, it's always no solution. There's no real solution. We'll say it that way. Doesn't matter. It doesn't matter what's on the outside. If you have square root of a negative anything on the inside, it's always no solution. Again, the difference between all three of these and this one is all three of these have negatives on the inside. This one doesn't. Okay, so this one's it's almost the same as the problems before it, but this case, instead of just being a number, you've got a number squared. And you can do this one in one of two different ways. If you think about 2 squared, 2 squared is 4, right? But what is a square root of 4? Just 2. Now, and again, that negative is on the outside, so it doesn't impact it, so the answer would just be negative 2. Well, technically, I mean, and that's what they're kind of going back and going to start showing you next, is if you have a square root of something squared, the square root and the square always cancel each other out. And that leaves you with just a negative and then with the 2. But in this case, they kind of go ahead and say, all right, well, and they're kind of walking up to that one. But yeah, if you have the square root of something squared, the square and square root always cancel each other out. But on the same flip of it, you could also just take that number, do 2 to the second power, go ahead and do 2 times 2 and get 4. And then you could square root that number and then put the negative in front there. Okay, a little different on this one. We're going to do square root of negative 5 to the 4th power. If you have negative 5 to the 4th power, that means you've got negative 5 times negative 5 times negative 5. And if you multiply all those numbers together, now even though they're negative, what happens when you multiply 4 negative numbers together? It becomes positive, right? So then you've got the square root of 625. And if you punch that in, that is 25. Okay, so basically on those, and whenever they give you the number that's here, go ahead and multiply that number out and get that one number of whatever that number is, and then you can come back and square root the number and just go from there. Sure, what you got? Okay, and the next thing they're going to do, they're going to change it from having to do just numbers. This time you're going to be this intro to simplifying a radical expression with an even exponent. Okay, that's a lot of stuff to basically say we're going to be doing variables instead of numbers now. So instead of doing 5 to the 4th power or 2 to the 2nd power, this time it's just v to the 24th power. Now, here's the way you can think about it. You can do it a couple of different ways. And we're going to kind of sneak ahead and show you something that's going to pop up later. Anytime it's square root, if we're doing square root, technically this is like the second root. To get this answer simplified, all you're going to do is you're going to take this exponent that's in here, as long as you're doing square roots, you're just going to take that exponent of 24, divide it by 2. It's going to be v to the 12th power. Now, they're going to explain it different ways, but to me that's the easiest thing, is sometimes they kind of sugarcoat some things in the beginning. Eventually, you're going to get to this where they're going to change this to where it's not an exponent of 2, where this is going to be like 3rd root or 4th root or 5th root, whatever. You're still going to do the same thing. You take this power you have here, divide it by this root that you have. That's the easiest way to look at it. So they explain it a little bit different when they go through this part of it and do some different things of it. But for what we're going to do, we're just going to take this exponent and just divide it by 2 for doing square roots. Okay, and they kind of use that to go to the next one, where we're going to do square root of perfect square monomials. And what this one's going to do, it's going to take the previous 2 examples you had, and it's going to put them together. You're going to do 25, the square root of 25x to the 10. Okay, and again, this one says square root, not square roots with an S, so we're only looking for, we're not worrying about the positive and negative. This one we're just going to get the positive. And you can almost break this one up into parts. That it's the square root of 25. And then it's the square root of x to the 10. Square root of 25 is 5. And again, for square root of x to the 10th, we're just going to take the x to the 10th and divide it by 2. So that's going to be 5x to the 5th. So if they give you a number and a variable that's together, just separate the 2, do the square root of the number, do the square root of the variable, and then put those 2 answers back together, and that's what you're looking for. Okay. All right, so let's give you... All right, let's just give you a different one here. Let's say you've got square root of 49y to the 12th. Right, if you do the square root of 49, we know that would be 7. When you do the square root of y to the 12th, that means you have to take the y part and take the 12 and divide it by 2. Well, the 7 is 7, so that one's good, but when we do 12 divided by 2, that's y to the 6. So the answer for that one would just be 7y to the 6. Okay, so everything is square root, square root, square root, square root when you're going through this one. Then they change gears on you just a little bit. This one we're going for cube root. All right, now the good news is most everybody's calculator is going to do cube root. So this is honestly one of those questions where punch it in your calculator. Okay. So you've got cube root of a negative 1,000. Now, and if you're doing cube roots, you can do cube, because what happens if you multiply the negative number 3 times? Negative times negative is a positive. One more negative makes it negative, right? So this one, you actually will get an answer if it's a negative. So that part's okay. So cube roots, it can be positive or negative. It doesn't matter. If you start off with negative here, that just means the answer is going to be negative. And what they want you to think about on this one is, instead of having to multiply the same number twice, you got to multiply the same number 3 times. So if you're doing 10 times 10 times 10, that would be 1,000. So you can almost think about it this way, that it's the cube root of negative 10 to the 3rd power. And if you've got a cube root and a 3rd power, they would knock each other out and just get negative 10. Okay. The cube roots of the integers, it's going to be, now you could do 1 times 1 times 1, which would be 1. You know, you could do 2 times 2 times 2, which would be 8. 3 times 3 times 3 would be 27. You could go back and make a list. Or one thing they did when we were working through the textbook all the time was they actually had a page where they had all the perfect cube numbers on there. So you could just go back and do like a quick reference of it. But with calculators, you know, now you can just pretty much punch in the calculator and get the answer that you're looking for. Okay, so they go from second roots or square roots to cube roots. And then they kind of jump to nth roots, where you're doing any particular root on this thing. So they say it's finding nth roots of perfect nth powers. Okay, so finding nth roots of perfect nth powers. Which again, it's pretty much just a calculator practice. Now they want you to go back and think about all the things that's here. That if you do the third root of negative 27, they're trying to get you to go back through your list. Well, back here, we just said that 3 times 3 times 3 was 27. So there's 3 3s. So instead of it being a positive 3, that would just be a negative 3. Again, if this is a cube root, you can have that. If this was square root of a negative number, you just put no solution. But then they give you another one here. We're going to do the fourth root of 81. Okay, now with fourth root, they're wanting you to think about, all right, what number could you multiply by itself 4 times that would get you to 81? Well, we know it's not 1. You know, if you did 2 times 2 times 2 times 2, that's not big enough. But if you did 3 times 3, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 would be 81. So if that's the fourth root of 81, that's the fourth root of 3 to the fourth. If you have a fourth root and a fourth power, now here's where they want you to kind of think about what we had here. Earlier, if we had just a variable, let me flash back up for a second. If we had just a variable, how we took this exponent divided by this root, if you can take a number and break it down, like 81, and this is where you'd almost go back to like your 6th grade math. If you took 81 and broke it down in perfect prime numbers, 9 times 9 would be 3 times 3, which would be 3 times 3. You could take 81 and rewrite it as 3 to the fourth. Well, what happens when you do 4 divided by 4? Just 1, right? So that's 3 to the first power, which means that answer would just be 3. So when we divided this power by this number with a variable, you can do the same thing if you break it down with just the numbers, that you're still going to take this power and divide it by this root. Well, in that case, it's 4 divided by 4, it's 1. Or just use your calculator. I'm not sure. Let's see what we've got here. This one is still an nth root of a perfect nth root monomial, which means it's got numbers and it's got letters at the same time. Now, we're going to do it just like it was if it was a square root, that you can break this thing up into parts, that if you've got the third root of 27 and v to the 9th, break it up into 2 parts. It's the third root of 27, and it's the third root of v to the 9th. Now, and this is honestly some of those, if you go past, once you get to fourth root and fifth root, some of the other ones, this part's really easy, because for the v, it's just 9 divided by 3. So that's v to the third. For 27, again, if you use your calculator, if you got the third root button, do the third root of 27. They also want you to think about that if you did 27, that's 9 times 3, which is 3 times 3. So that's the third root of 27 would be 3 to the third. So those third root and third powers would cancel, which would eventually just get you 3. So final answer you're looking for would be 3v to the third. All right, for example 2, they bump it up to fourth root. We'll go 4th root of 81y to the 12th. You've got 4th root of 81, and then you've got the 4th root of y to the 12th. Okay, now, if you go back to the earlier problem we had on that one, 81, we broke that down just a minute ago. It was 9 times 9, which then left you with 3 times 3 times 3 times 3. So if you broke this one down as far as you could break it down, that would be 3 to the 4th power. This one, you got 12 divided by 4. And again, if you get so it's the 4th root of 3 to the 4th, that's just 3, and then 12 divided by 4 is 3rd power. Okay, now, and I think technically that's what they want you to do with the whole number part, is with the whole number part, they want you to break that down using the old factor tree that you did back in 6th and 7th grade. And you break it down until you've got just 2s, 3s, and 5s. Well, in this case, if you took 81 and broke it down, you've got 4 3s, so that would be 3 to the 4th power. And once this power and this root are the same, they'll cancel each other out and give you just the number that you had there. You want to do one more of those? Okay. Let's do the 3rd root of 125 x to the 15. Okay. Now, again, with the variables, this should be easy because it's just 15 divided by 3. That's x to the 5th. For the 125, again, if it's easy to work with the calculator, you can. What they really want you to do is think about breaking 125 down. If you do, that would be 5 times 25. 25 would be 5 times 5. So if you took 125 and broke it down, you would have 1, 2, 3 5s. So that would be 5 to the 3rd. And if you have the 3rd root of 5 to the 3rd, that 3rd power and that 3rd root cancel each other out. So it would just be 5 and then x to the 5th. Okay. And that will finally get us through 10.1. That was all just 10.1. Now, we'll go ahead and let's go ahead and do 10.2. There's only 2 objectives on 10.2, so we're going to go ahead and do that one because it'll take just a couple minutes to go through that one.